Hi, I'm Tori Earl, and we are Havelock Metal. We're taking a look today at installing our majestic rib profile on a roofing application. Now, the procedures and methods that we'll use here today are typical best practices, but don't cover every scenario. If you have any questions about what you see here or other methods you may have heard of, by all means, please feel free to get in touch with us. We'd be happy to help. Let's get right to it. As you mentioned, we're looking at installing our majestic rib profile, and the techniques and methods we use here on our roof application will be the same that we would look at for our diamond rib or our delta rib styles as well. These are all rib steels that receive a fastener through the surface. So the setups we have behind us here is a roof that has been prepped. It's got a membrane on it. It's been strapped accordingly. And this side, we're looking at a roof deck that has a membrane applied to it, where we'll be applying our steel direct to deck. Now, for more information on membranes and strapping, please feel free to refer back to our website. There's lots of information there for you. So what goes on first? Well, we look at our perimeter trims being installed first. And if we can keep in mind the flow of water, we want to start with our trims at the bottom and layering on, working towards the top, creating that cascading or weather shedding effect. So the first piece we're going to put on is our eave starter. So this is a piece of eave starter. It runs along the bottom edge or the eave line of the roof. We've gone ahead and installed it here, and we'll take a closer look at that in a second. But what I want to point out to you is Havelock Metal will make your eave starter specific to the pitch of your roof, or customized to your roof, if you will. The point is it will seat nicely against the roof and nice and snug against the fascia line. That provides both a form and a function. The form in that it looks nice and clean and neat. The function in that it does cover up the edge of your strapping. And provides a space that we get to slide our fascia up in behind and not have to have any accessory fasteners in the face of our fascia. So, like I say, we've installed it on the strapped version here. It's very easy to see. We've just gone ahead with a flat screw, pancake screw, and it finishes off nicely. Now on the membrane roof there, you can see the differences. We had the opportunity to have the membrane rolled over top of the eave starter, again for a weather purpose. That's just a smarter fit. Now, before you install the eave, there's a couple of transitions or connections that you might want to consider. One, where it's meeting into another eave starter, as well as where it's meeting into your gable starter. There's a certain way that we can cut this for best practice. You could just install it and leave it as a raw edge and have your gable starter come right down to it and simply butt them together. But with just a little bit more forethought, you can cut back your nail flange and cut back your drip edge and fold over the face portion like we've done here, and it just gives a nicer, cleaner look for when the gable starter comes down and ties together. So we'll take a look at the gable starter now. Our gable starter looks, in this version, looks a lot like our eave starter. Again, that fundamental difference where the eave starter is pitched to the slope of the roof. The gable, as it sits on the 90-degree edge of the gable, is kept at a 90-degree bend. Now, it's important to note that all Havelock Metal trim we do out of a substantial 26 gauge material. It's a nice hardy, stiff gauge that will provide a real clean look and really enhance the look of your trim applications and the overall appearance of your project. So again, they also come in 10-foot lengths. Gable starters in particular, there's several versions that you can consider. Like I say, this is a very straightforward, simple one. But we often use a version that looks like this as well, referred to as a flying gable starter. Now it's specific to a flying gable roof style where your ridge is longer than your eave and your gable ends have this proud sort of triangular look to them. It's important to use this on those roofs as your steel is applied and your ribs are cut according to that angle The rib cross section is opened up quite a bit, being cut on that bisection, and the concern about weather blowing in there is something we want to address. So it tucks nicely into this sort of J portion of this trim, and can really provide a finished look, such that it's become quite a popular look in regular gables as well. So you can see we've went ahead and we've installed a flying gable on our roof here, and like I say, it gives you a great finished look. So let's take a closer look at the connection between our eave starter and our gable starter. We talked about cutting back the nailing flange and the kick, so that we left some of the face of the eave starter to wrap around the side and to give that nicer finished look. This is it in a little bit of a closer up view. You can see the nail flange has been cut back. The kick has been cut on an appropriate angle, and we've folded over the face. So also on our gable end, we've cut it to the slope of the roof, and we've created a detail on the kick that where they go together, it creates a nice tight finished appearance. So when joining gable starters along a given run, again, we talked about these pieces being in 10-foot lengths if your section is greater than 10 feet and you need to lap pieces together. Again, whether it's gable or eave, we look at a very simple overlap, where again the lower section is installed, and then the higher section laps simply over top, again to maintain that water shedding effect. It's important to have this lap be quite minimal, really. Just about an inch is all you need there. The point is that we're trying to keep this as flat as possible, so as the steel lies over top, it doesn't have some odd sort of raised section to it. The greater the lap, the less tight that will want to sit. And this is an area that has steel over top of it anyway, so we're not really concerned about water getting into that lap. So again, less is more in this case. And that's a simple, straightforward gable and eave touch. When we're trying to splice flying gables together, however, there is a little more to it. What happens here is we want to have, again, that cascading effect where the top is laying over the lower portion. So we would relief cut away the back part of our flying gable, leaving the nail portion of the flying gable, while on the lower part we will cut away, we'll open up the catch here, so that we'll better be able to lay in the upper portion. Now you can see in this case here, we've got it lapped nicely. The lower portion was opened up, and you can see the evidence of the tooling happening here, which is really negligible. Again, the steel covers that. It's not seen anyway, but the important part is we've maintained this water flow down the whole run of the trim. And again, it will provide a very finished look from the outside. So the next step in our process could be our valleys. There are a couple of forms of valley to consider. This is a V valley, named for its actual V shape. But you'd see this traditionally more of an asphalt shingle application, where your shingles will lay over top of your edges, and it creates a very uniform seal down both sides, and weather can typically run down nicely. Where the other one that we consider is what we refer to as a W valley, and again, because of that W shape. Now, the importance of this guy is, as weather wants to run from one slope, it's running in a downward direction, but as it gets off of the steel and into the valley pan area, it can come at such a volume that it may want to splash or ride up the other side of the valley. This little W acts as a dam, if you will, and tries to assist in diverting the water down and off of the roof. So we're looking at the actual application of the W valley. Now we've installed it here on this roof, and we've cut our bottom edge to accommodate the angle of the roof, as well as the angle of the ridge of the roof as well. And what we've looked at is our very typical 18-inch valley. You can get these in different sizes, 24 or 36. The notion being, as we talked about, that water rushing from one slope down and into the valley and possibly riding back up the other slope. Again, this is a very extreme angled roof that we're talking about here, so lots of stuff is running straight down anyway. But for visual purpose, this extreme angle is nice for viewers to see. But on regular pitched roofs, perhaps, that water rushing from one slope to the other and possibly getting under the ribs of our adjacent steel is a concern. So the notion, like I say, maybe to go to a bigger valley, a 24, 36, like I say. The thought process there, though, I might caution, yes, you get more protection under your steel. So any water that wants to run under there has still some protection on that trim itself. But what happens when you lay your steel over top, and we'll see a little bit later, the fasteners for that steel run through the valley, and essentially you're puncturing that 24 or that 36-inch valley. So that's not so great. We thought we were trying to use that to keep water out, and we've just put a bunch of holes in it. So Havelock Metals theory is the reality is we actually even go with an even bigger valley, and to produce that we will use an ice and water shield. So like I say, you've got your 18-inch valley in place, and then we've run a course of ice and water down that covers the fasteners, so that's nice and sealed, and it gives us an additional 3 feet of coverage on that valley. 3 feet on this side, 3 feet on that side, plus the 18-inch valley in between. You're talking about 7 feet of protection. That's very safe. There's no worries about water rushing under the rib and causing any damage. It will be free to run back out. It might be important to note at this point as well, there are other products on the market in the form of foam closures. And some folks may think that they would like to stuff or fill those open rib voids. And that may work, except there's so many different pitches and so many different angles. No one foam closure can accommodate them all, and you may create a scenario where you've blocked water from getting in one portion, but not another. So allowed some to get in, and then the water's behind that closure and maybe now can't get out. So again, the Havelock Metal theory is we keep that open and let the water run free. It may go in, but it certainly will travel back out, and it's well protected behind the steel anyway. So that's how we treat our valleys. A little technique that you can try to give yourself a little more of a refined or finished look for your W valleys could be a closing of this W end. You'll see that we've marked our piece here with some Sharpie. We're going to cut away these portions, leaving just a single tab there, and fold that over closed. The effect looks sort of like that. And again, it just gives you a little more of a refined or a finished look. Now with our perimeter trims installed, we're ready to apply our roofing panels. And you can see we've gone ahead and put a couple on entering in our valley here on the roof behind us. Now the panels themselves ideally might be pre-drilled. So you're going to take some time to lay out your course of drilling pattern subsequent to perhaps your strapping. And that's typically on a 2-foot center. But let's keep in mind when we're pre-drilling our sheets, if we're using any of the offcuts to rotate around and use in a different spot on the roof, maybe we don't want to pre-drill those sheets until those ones are ready. Likewise, where the sheet might overhang at a gable edge, that final edge does not need to be pre-drilled. We don't want any holes in that, obviously, if it's overhanging. And in our case here, it's going to be tucking into a flying gable channel. So again, that doesn't need to be pre-drilled there. So we can go ahead and apply our steel. You're going to go ahead and put your screws in. Putting a screw in the steel is pretty simple, except let's again keep in mind there's a rubber gasket that is doing all the weather protection for you. So we want to make sure that's used properly and well protected. The screw itself will have a steel shroud above the gasket to protect it from weather. But as you drive your screw in, make sure that it's at a nice straight line to make full contact with the steel. And what we're looking to do is just compress that gasket slightly. Over tightening might feel good and make you feel good and secure that you've got a good tight fasten. But you probably have distorted that gasket, and it's now going to be a source of leaking where it was supposed to be what was keeping the water out. So do not over tighten these, just compress slightly. So as we said, we've got our sheets, our opposing valley sheets applied already, and you might have, again, a little more forethought into the layout of your sheet application in regards to lapping, in regards to predominant weather direction. More importantly, you may have also considered what sort of protrusions you have in your roof. For instance, this pipe vent or plumbing vent coming through our roof. We'll deal with how we flash around that. But at this stage, as we're applying the sheets, we now get to decide where we want our sheet to land in reference to this penetration. We've chosen to have it occur right at a rib because we, again, laid out and had the foresight to measure out and understand where our valley wants to be cut so that we get to have this occur in this setup and we can treat it easily. Plumbing stacks are one thing. You may have other protrusions like chimneys or skylights. Let's take a look at a skylight now. So as we discussed, the placement of your sheets in relation to protrusions in the roof or obstacles on your roof, like a skylight, for instance, in this case, this box simulating a skylight for our purpose here. Because we know where that's lying, we had the opportunity to cut our valley and work across the roof and around our skylight, where the ribs are falling on either side of the skylight. It's fitting perfectly between these two ribs. It really doesn't matter what size that skylight is. The function or the purpose is the same. You get to have some control over where these ribs start and stop so that you can better flash around it. Now, let's look at flashing skylights in particular, skylights and chimneys and plumbing stacks in particular. We'll touch on all of them as they're a very common question that lots of consumers and customers have as they're a common leak source. So we'll get to the flashing, but a little detail I'll point out first here is you can see the sheet is applied around that skylight, and we reliefed cut out this entire portion of steel and have now laid our sheet into and around the skylight and left an uncovered area above. That's because we want to give ourselves the opportunity to have our flashing above the skylight under the steel at the same time as the flashings on the side and front of the skylight to be on top of the steel. This is one way to achieve that. So let's grab those trims and we'll take a quick look at how to flash the skylight. So when we're flashing our skylight, as we mentioned, it is a very important area. It's often a source of compromise or a leak potential. But if we look at what we're doing here, it really is just the use of sidewall flashes and end wall flashes, still oriented slightly differently perhaps than traditional sidewall end wall functions, but the point is they sit on top of the steel. Now we can see that when we have a sort of a simulated miter edge here, we've actually brought the actual joint down farther past where the actual skylight finishes. The idea here is that water rushing down here finally gets off of this sidewall flash and onto this front panel well away from the actual small pinhole that could be created by your laying over the trims. So it's a very safe area for water to get off. We've bent up the end wall or our bottom pan, if you will, such that we've created a tab in which the upper portion of our sidewall flash folds over and onto and creates a nice finished look here. That's the same sort of function as at the top here with our top panel. It has been cut back and folded over onto a tab that we folded up for our sidewall. And again, as water's rushing down from above, it's hitting this flashed area on top of the skylight, and it's getting off of this flashing well past the penetration point over here. And again, it's just a nice, safe way to protect that skylight. Now, because we still need to finish the area above, we've cut ourselves a sheet that will be applied on top of this panel in this kind of configuration. And again, it marries nicely to our rib spacing. So we're well protected here from a weather standpoint, but there's still some accessories that can be used to make this even more weather tight in the form of closures. What we're asking water to do essentially is to breach this sort of assembly. You're looking for water to be rushing down and somehow be blown or to migrate underneath this trim and climb over top of this rib before it gets anywhere near this skylight, which is unlikely to happen. But in the unlikely event, we can help further prevent that from happening by using a foam closure under this particular piece here. As well, like I say, this overlying steel to create the finished look here. There's a closure that we can apply underneath, and where we have our bottom flashing over top of the steel, there's a closure that we can apply under here and keep this all sealed. Let's take a look at those closures now. So we've applied our top sheet here above our skylight, and we've left it fairly loose so we can better illustrate the ability to slide in our foam closures. Typically, you might apply this foam closure to the back of this piece prior anyway, but we'll take a closer look at that. This is our sealant foam that we might run down our sidewalls, especially when it's protecting a chimney or a skylight. The idea is that it has a self-adhesive back, so I'd peel this off, I'd apply it underneath this trim prior to putting the trim on, and this particular foam will expand up to 1 inch. So as it's applied, it's actually a little thinner now than it will be as it's exposed to air, and it will expand in that cavity and create a nice tight seal. So these closures, like I say, they come with an adhesive on them, which will adhere to the underside of the steel. We refer to this as a small tab closure, meaning it closes off the small tabs or openings in the rib. So this would sit under this steel and create a nice seal all across there. Again, if any water wanted to migrate up and underneath any of this assembly, there are still these 2 ribs underneath of all this that it would have to climb as well before it caused any damage. And again, very, very unlikely that could happen. Subsequently, we talked about putting this trim under our flashing here. This is referred to as a large tab because as this flashing rests over top of the ribs, a larger tab or cavity is created there, and that's where your large tab closure will slide under there. Again, it's got a self-adhered strip on it, so it will stay in place and protect this skylight for years to come. Now, of course, we want to rely on the steel to keep the weather out, but the closures are a nice addition to, as well. Of course, feel free to caulk any areas that are of a concern for you. It's a nice security feature as well. So as far as the chimney flash goes, everything is very similar or almost the same as the skylight version, except of course, instead of our flashing coming off of the roof at a 90-degree angle, it should be pitched specific to the slope against the chimney as it's coming out of the roof on an angle. But it's important to note all those same sort of principles where we have one flashing folding over the other and the drainage happening well away from the actual penetration point. That's another key element. You can see we repeated up top again. We have this angled back panel that's folded over, and where the water is getting off is well away from the actual pinhole that potentially could be there as a result of the overlapping flange. Now we've gone ahead and applied our upper panel as well, which again makes the upper flashing or the back pan results in the back pan being under the steel while the rest of the trim is on top of the steel. Kind of a hard thing to describe or to do, but you can see it here and it works very well. It's important to note this back pan, we want to have enough space for water to get off of the upper roof portion and have free access to run on top of this panel and get off of the edges. It would not serve us to bring these ribs right down to terminate into this panel, as we would be creating a bit of a pool effect between these ribs against this back pan. So it stops shy of this point here, so that water can get safely off and escape and get down the rest of the roof. Now, on our sample here, you can note that we've got a folded edge at the top flange of our sidewall or end wall flashing. That's an option that you can have Havelock do for you. And in this version, it's tilted away from the chimney. This may be a masonry chimney, it may be a stucco chimney, what have you. But what this is referred to as a caulking edge. So this edge here will allow you to lay a bead of caulking in and will be held in place nicely and supported and last for years. There's some small variations. We can make it straight. We can actually fold it 90 degrees into the chimney, and you could do a relief sort of like a curve cut into your masonry so that trim can actually tuck into there, and that can be caulked after as well. So a couple of different options that you can get these trims done in, and all totally customizable through Havelock metal. So there's your chimney. We discussed the skylight. Let's take one more quick look at plumbing vents. Okay, so we're flashing around a plumbing stack here. We've had our sheet on here prior, and you may have seen that we've already sort of cut half of it out to fit around this pipe. And again, because we laid our sheet work out so that we could cut into the side of a sheet, that worked out very well for us. When we go apply the other sheet, we'll cut out the other half and lay it over. So that's all well and good in a world that you get to lay those sheets out. But if you actually have to put a hole in the middle of your sheet, how might you do that? There's a few different ways. You can certainly mark and measure and cut your hole accordingly and slide your sheet over top. But another popular way, would be to do a sort of a scissor effect of your sheets, where you cut a portion of your bottom sheet out and overlay a top piece. I have that done for us here, so let's take a quick look at that. Now, for the purpose of our demonstration here today, I've just sectioned this sheet off, so this could be on a full 3-foot wide sheet. Maybe it's in the middle, maybe it's at the beginning. Regardless, you can see here that it will overlay this pipe perfectly. We'll screw it in place. We would then cut out an upper portion and lay it over. Screw it in place. And now we've got the sheet applied nicely, as tight as we can around our pipe. and we're ready for an additional pipe flashing, and we'll take a look at that now. We have our other panel of steel applied, and it's nicely fitted around our pipe, and we've gone ahead and installed a pipe flange, or roof boot, if you will. They're a great accessory to roofing, and can help seal lots of different round protrusions that come through, whether it's another chimney in particular, or perhaps a power vent or a power line, like an electrical mast. But this is the typical shape. You'll find it to have a malleable edge to it, a malleable steel edge over top of the rubber gasket itself, and that can be articulated to form specifically to the undulations of your rib, so we can get a nice tight fit. Of course, we would apply caulking to the underside, and then we'd go ahead and we would screw in place all the way around. And this is an important note that would have been covered in our strapping section, of course, but you may recall we have strapping lined out around this pipe specifically to accept the screw that we want to secure this pipe to, this roof boot to. I'll show you real quick here on the roof boots themselves. There are numbers here that show what size of pipe you're dealing with, so you can assess exactly where you want to cut this pipe. For instance, most plumbing stacks might be a 4-inch ABS pipe, and you'll cut at the 4-inch point. That 4-inch doesn't mean your hole is exactly 4 inches. It's actually a little less. That gives you a nice tight compressed fit, and that's how you get that weather seal. Again, our roof display today is an extreme angle, and fortunately the industry will provide an extreme angle boot, so it can accommodate that nicely. So if you have a condition on your roof where you have a pitch change, there's a couple scenarios there. In this version, we have a pitch change happening where a high slope is transitioning to a low slope. How we deal with that is with the use of what we call an under-over flashing. This is the actual piece here, but you can see in our illustration, we have a 12-12 roof pitch here. We have steel laying on top of our flashing, which the upper portion, of course, is under the steel, and it overlays the steel portion on this 412 pitch, of course, over the steel. That's where the name comes from. This is easily flashed with your solid tab closures, again on the bottom where we're closing up the large open tabs, and the small tab closure, which would be applied at the top where we are filling in those small tab openings of the open ribs. And it's the same function, if you will, where the reverse scenario is true of a lower slope version transitioning to a higher slope or a greater slope version in the gambrel roof style. Again, the trims look very similar. They're just oriented slightly different. Of course, again, the steel roof is over top of the upper flange, and the lower flange comes out over top of the steel, and we would treat that with the same type of closures to seal and protect those areas. So what we're looking at here is the use of cap flashing. Cap flashing is used on roofs that have a single slope or mono slope. So as the slope ascends to a peak and meets at a fascia, this is where our cap flashing will cover and protect the roof from weather getting in, blowing down from the top. You can see that closure can be used under here to seal to the roof. Closure is an important factor for sealing. As the saying goes, steel on steel isn't a seal, so we want to make sure we have some type of foam or caulking or some type of treatment between that to really make a seal weather tight. In this case, because it's at a peak, we have the opportunity to vent this roof potentially, so that closure can be vented, or solid if there isn't any need to vent. So when applying our sheets, it's important to understand the lapping, or how one sheet sits over the next. In this version here, our Majestic version, we can see quite simply there's a side that has a tail, if you will, or a longer flange, compared to the other side that simply finishes at the termination of the rib. This is to help identify the underlap side of our sheet here. And again, specific to Havelock Metal's Majestic rib, the configuration of the rib is slightly different than the rest in that as one sheet lays over top of the lower sheet, a small gap is created at that rib joint. That small gap is referred to as an anti-siphon joint. And what that is doing is stopping water from being wicked or siphoned up over top of the rib, and of course then compromising that rib joint. So it's important that it's laid out and followed in that pattern. I'll just lay this other top sheet over so that you can appreciate. That's of course the nice clean finished look, and there's that little gap that's created to maintain the anti-siphon joint. So some very common questions we're often asked relate to some sort of problem areas in roof installation. In our setup behind us, we can see we have a dormer coming off of our angled roof, and this will give us an opportunity to address a lot of different functions, in particular where valleys meet ridge, where ridge meets hips, as well as areas where our valley will open onto the roof system. So we'll address each of those and discuss how we flash those areas properly. So let's get to it. So the first item we'll look at is the valley. Again, in our display here, this is for function purpose to understand how trims are laid on, and we'll look at how they're cut. Of course, in a real life scenario, this would be a membrane would be applied. Potentially, this could be strapped as well. But again, for our purposes here, we're concentrating on the function and the connection points of these components. So our W valley, we want to lay into our valley portion here, and we'll see that it's been cut in such a way that as it sits on the roof structure, it has a flange that folds over the opposite side of the valley, while the rest of the material is free to run up the roof. Now, it's important to understand the W portion of this valley doesn't end at this point of your ridge. It ends at the connection point of the opposing valley, and I'll show that a little clearer here. So we've cut these pieces such that they will marry into each other well. Now we've done a couple of extra details here where we have folded closed our valley portions, or the W portion of the valley. That just gives you a greater area to apply, or a safer area to apply caulking, and it'll be held well in place. And it looks nice and neat. It gives you a pretty good seal as is, but bear in mind, this is all being covered by subsequent trims as well. But we're giving ourselves the best starting point that we can here. So there's our valley applied. Again, you can take a closer look at how we've cut back, folded over, closed the W portion, and we've left this other tab to run long, as it can still provide some weather protection. So there's no point. We could have cut it off, but leaving it on will help give that area extra protection. So we'll now look at our hip application, and then we'll put our ridge on. So with some steel applied into our valley and on our hip here, we'll look at our hip caps. So a pretty simple design here being used. just a 4-inch flange with a hem on it. Of course, you could choose whatever style cap you'd like for your hips if you want them to match your ridge caps. In our case here, this isn't a very big hip, so we're going to keep our cap kind of small. And again, with all of the Havelock Metals trims, they are 26 gauge, they are 10 foot in length, and they're customizable. So if we wanted a 4-inch versus a 3-inch or whatever size, happy to do that for you. So of course, on a hip, we're going to overlay we're going to apply, our foam closure on this area. So as the hip seals, we'll have a nice weatherproof connection. And I'll show you quickly here. That's the end of our hip. I've gone ahead and folded over our top portion, much like we folded over the valley edge. It will serve us to catch over on the opposite side of our roof. So that will lay in place. Our subsequent next hip, we've marked and we've measured and we've cut off the according angle so that as it overlays, it has a nice junction, and we'll see when we put our fastener on, it's all held together. This creates, again, a nice, tight, clean joint, and we'll go ahead and we'll apply our ridge cap to the top. So in applying our ridge, where it's intersecting valleys and terminating at a hip junction, we've chosen the same sort of hip style for our ridge. And you can see we've marked, we've measured, we've slit down the middle, and we've folded back appropriately so that this ridge flange will marry up nicely with the degree of slope on the roof, and will close in nicely over top of our W valley trim, and extends across, of course, across our ridge, and will terminate. We've also marked and measured, and we folded back, and you can see that we will put a fastener in here that'll hold in place, and we've created this nice continuous line straight down the hip. It again provides for a nice clean look. There's one thing I'll point out here. What we did here is this ridge length we actually brought out a little further than where it actually terminates. And the reason for that is your joints can be cut clean and nice and tight, but ultimately you'll have overlapping trims here and a consistent pinhole at this peak. So to help protect that, we brought this ridge out slightly further than where that peak stops by about 1/2 inch. And then close this over. The idea there is this is going to be a nice tight joint. It's going to have some caulking behind it. Chances are it'll never leak, but in the event that it does, it doesn't have anywhere to go because, again, it's not placed over top of that sensitive pinpoint area. It will simply drain out, and again, the look is nice and clean. So as we look at how it terminates, again, back on our valley portion, that same notion of those overlying trims and that consistent connection or junction, if you will, point, that potentially there's still a small pinhole to deal with. Again, because there's so many layers going on here, and the addition of caulking on those layers, you're creating a scenario that is very sound, very weatherproof, but ultimately we would still maybe look at an additional flashing to be applied over top and to close this all in, and you get this nice clean effect. So lots of sandwiching to this layer, lots of opportunity to apply caulking, so you can create a very nice tight seal here and a worry-free joint for your roof. So we've went ahead and we've applied a sheet portion that will terminate into our valley. But as you can see, this valley doesn't terminate at an eave portion. It terminates at an eave portion on the dormer, but on the main roof section here, it stops and needs to come out on top of the rib steel. So your options here, you could cut this as one full length sheet and you could manipulate and slice in your sheet and have this valley feather out on top. But you run into a lot of issues with how to seal that properly. It's a complicated cut, and it's such a sensitive area. I'm going to suggest we look at doing this in a two-piece scenario. So the sheet we've applied will come to the end of our valley, and now what we're looking at doing is applying an additional sheet. And the idea is we want it now to fit up underneath our valley and slide up underneath our upper steel. Again, we're looking at maintaining that cascading water effect or water shedding effect. But the reality is I've got a rib connection here that is impeding this valley's ability to maintain a flat installation against our roof deck. So how are we going to deal with that? Well, there's a couple of options in here, but one that I'm going to suggest again, we're going to slice this rib down to an appropriate length that'll allow me to slide up this sheet, and I'm going to close this rib on itself, thus making a flat section that will be able to slide up underneath this valley freely. Now that's going to leave me with a slice of my steel. These offcut pieces will overlap each other, but I'm going to seal that with an additional piece of ice and water shield, and that'll allow me to slide that piece up underneath my valley, maintain my rib placement with my panel above. And of course, if this were a real dormer, we would have a sidewall here. So we'll cut away some of the additional steel here that would meet into a sidewall situation. We'll take a look at that now. Okay, so we've gone ahead. We've made our slit in our rib. We've manipulated this down so that we have an underlap and an overlap type of scenario here, and that's really closing that back off. And that in itself is a lot of protection. But we're going to go ahead and we're going to apply an ice and water membrane here. Now, for our display purpose, I haven't peeled the entire backing away, but you can see what's happening here. This will seal this up completely. I've relief cut out this portion to better slide up under our valley and meet into the dormer situation. And this is the effect. They've created an area now that our steel can slide under our valley. That rib portion is sort of out of our way, and we get to slide it up under our upper sheet. So we'll work at aligning this as best we can, but ultimately you get a very clean look. Our valley is coming out on top of our lower steel. This sheet is going back up underneath our upper steel by several inches. If we wanted to lay some caulking in there as well before we slide that in, we're going to screw this in place, and you'll have a great weather-tight seal. This will function for years without any concern. So we'll take a quick look at how to terminate our hips here. You can see we've applied our hip, and this one was not quite long enough. I wouldn't suggest in a real application that you have a joint this close to the end. I might have wanted a joint at a little bit higher up portion. It just is maybe visually a little more accepting to see a joint halfway up as opposed to right at the end. But for our purpose here, what we're focusing on is how to finish this end treatment. So it's easy enough to slide up a piece of hip that gives you the additional length that is required to finish that run. But if we maintain the line of the steel at the eave on both sides, transfer that to our hip piece, we've cut and we folded over, and this is all closed off at the end. And again, this just provides a nice finished detail and closes off the end of that hip. So we're now at a point in our project where we can apply our ridge cap. The cap style that we've chosen here is referred to as R8, R being ridge cap, 8 referring to the fact that it provides us with 8 inches of coverage on each side. That leaves you or affords you plenty of leeway when you're applying your sheets if there's any sort of wiggle room that's necessary or needed or required because maybe the sheet wasn't as long as you wanted it to be. An R8 cap gives you plenty of coverage and can help in those situations. There's a little step halfway down here to increase its rigidity. It's a great cap option. So we're going to look at applying this to our extreme angle roof here, which is another thing that our R8 does because it's got such a long flange on each side. It can accommodate those steep pitches. So pretty straightforward to cut at your intersection at the top of our valley here. Again, because we have the step down design. What you're going to do is make a slice cuts into your termination point at each bend joint, so that as you fold these sides over, we maintain that design of the cap. Same thing happens on the inside, of course. We've folded over our flange so that when our opposing ridge cap comes from the other side, it will lay over and create a nice joint detail here. Let's see if I can hold these up for you to show. That essentially is the effect that we're achieving. And once, of course, this is on the roof, I'll have the ability to manipulate that, and that'll be a nice tight joint when we go to install it. So with our ridge cap connection point established at our valley, we can see that this cap is running short of the full span, which gives us a good opportunity to address how to lap our ridge caps. It's very straightforward. The profile will suit itself to nesting over top of the previous piece, but that is a sensitive joint there, so we want to make sure we're using caulking, and it's a good idea to point out. I want this lap connection to happen past a rib joint. So instead of just overlapping a few inches, I want to overlap at least past the next rib. That's going to give me the opportunity to put a fastener through both my new over-top ridge cap, if you will, in through my underneath ridge cap, and that's going to create a nice sound, tight, weatherproof joint. Now, as we look at this end of our ridge, we're going to have a situation where our cap will end and we'll have this open space. So it is possible, again, to make these relief cuts at the profile lines and fold closed this end. But another thing that Havelock Metal will do for you is we can create end caps that will be customized to the appropriate slope and style of ridge cap that you're using. So it'll fit in nicely, whether you want to have it out flush or whether you want to have it inset slightly to provide a bit of a reveal, a little bit of caulking, and your screw points will seal off the end of that ridge cap nicely. So again, with looking at our ridge cap application and our little saying about steel on steel not being a seal, it is important to put a closure under these ridge caps, whether it's a vented one like this one or a solid foam. The point is it'll be applied along the steel underneath the cap at a point where we don't want to have it exposed to UV elements as best we can. So I'd like it to be up high enough that it's shaded, but not far enough that it creates a pocket where pests might like to maybe create a home in there. So somewhere around this kind of point is appropriate. I'll bring it back out to this layer so we can see. We'd find it somewhere around this kind of position. This is going to allow us to have our fastener go through the ridge cap sealing through the foam, and again in through the steel, and then in, of course, to the roof deck below. So that gives you an idea of how to apply the vented closure. And one of the last things that you might consider doing, of course, is the application of snow control or snow stop. Again, you can consult havelockmetal.com and look at different reasons and different applications of snow stop. But again, snow stop is typically one of the last things that you might install. It's quite simple. You have a fastener that goes through both the front of the snow stop and the back of the snow stop, and it sits on the ribs. Again, a good idea to put some caulking on top of the rib just at the screw points for your snow stop, but that will secure that in place nicely. And again, you'll get the full function of what a snow stop does for you. So that wraps up most of the elements that we can think of for roof installation. But again, as always, if you have any specific questions on something you haven't seen here, by all means, please feel free to reach out to our office. We're always happy to help.